basic statistics. Like this. When they say statistics, what do you have in mind?
Numbers,
Numbers.
comparisons, relationships.
Statistics is a tool to examine relationship. Okay, relationship can be similarity, can be difference, can be correlation through using numbers in a numerical way. Okay, that's a statistic. Examine relationship using numerical tool. Okay, so that is a statistic. Okay, so when we talk about statistics, you always talk about the variable. What is variable? Yeah, anything varies is a variable, right? That's variable. So we have qualitative variable, we have quantitative variable. Remember last time we talked about it, when you measure variable, there are 4 levels of measurement scale, right? What is the first one? Nominal, ordinal, interval,
ratio.
right? 4 levels. Okay, so these 4 levels represent the hierarchical order of the measurement accuracy. Okay, so in the nominal, you don't need to have any numerical value. Even though some variables in the database are coded like a gender, female 1, male 2, that 1 and 2 are still labeled, no numerical meaning. Okay, then the ordinal give a little bit of measurement accuracy there, you can rank order them. The interval, in addition to rank order them, you can measure the difference of the values, right? The ratio, in addition to measure the distance between the values, and then you can do ratio comparison, right? You have true 0 there, so you can divide, you can multiply, okay? So that's a variable. And also the independent variable, dependent variable, last time we talked about it. Independent variable, there are 2 types of independent variable. Okay, in an experimental study, there is an active independent variable which is manipulated by the researcher, which basically is an intervention. Okay, give intervention or do not give intervention, or give the level of intervention. So that is an active independent variable. Another type of independent variable is attribute independent variable, or assigned independent variable. Basically, it's people with some characteristics like gender and ethnicity. The dependent variable is basically is outcome. Okay, is affected by the independent variable. Okay. Measurement, assessment. Last time we talked about it. Levels. Already talked about it. Then this is importance between the population, sample, descriptive statistics, and inferential statistics. Last time I had you study descriptive statistics by yourself. Okay. Today we mainly focus on inferential statistics. There's some relationship among this. You know what is a population? What is population?
Everyone in a group. Everyone in a group.
Okay. Population is the focus of the study. It's a target group of the people you want to draw conclusion about it. Okay? So that is the population. Okay? All right? So this is the people you want to draw conclusion about it from your study. Then what is the sample?
Part of that.
I know it's a part of it. What's the function of the sample?
It's representative of the population.
Representative of the population.
Of the whole group.
Did you study sampling by yourself? Yes, you did, right? You did
Yeah.
homework. This is the people participating in your study. It is, you're right, it is part of the population, the subgroup of the population is a small number of the population. They're all right, but the key is the sample, is the people who participate in the study. Right? So you draw a representative number of the people from the population who participated in your study, then you can collect data from them. Without sample, you do not have the data. Population in education, most of the time is dynamic, is unobservable. For example, suppose you want to study 7th grade student reading proficiency. How's that? This year, you said, I want to include as many people as possible. This year, you draw all the 7th grade students from all around the world. How's that? Next year, a different group of people, right? And even you spend like the rest of your life to collect 7th grade students reading proficiency. Then after that, another group of people come, right? So it is dynamic, it's unobservable. It is impossible for you to include all possible every individual in this population in your study. It is dynamic. Whoever participates in your study is a sample. Okay? So that's why the sample drawn from the population, then what is descriptive statistic you study?
It's numbers to use to summarize the sample.
Exactly. Descriptive statistic is to summarize your sample data. So you do have a number for descriptive statistics because you calculate it and you compute the sample value. That is descriptive statistics. How many types of descriptive statistics have you studied?
2.
That's the type of variable. How many types of descriptive statistics you studied?
2.
There's the
4.
measures of central tendency and the
Averages.
Let's count it. How's that? Frequency, right?
Yes.
Frequency of the distribution, right? Second, measures of a central tendency. You just said the mean, median, mode, right? What's the third one?
Distribution variable.
Yes,
spread.
distribution variability. The third one, standard deviation, variance, range. This all variation, distribution variation. What's the fourth type?
Correlation.
Yes, correlation. So statistics in the whole wide world only 4 types. You think statistics is very complex, but if you categorize them only 4. Only 4. Any statistic is dealing with one of them or combination of them. Descriptive statistics, only 4 types of it. Okay? Have you heard of any other statistic? No, never. Only 4 types. People think statistics, there's so many, so complicated. No, only 4 types. Okay? Okay? Only 4 types of descriptive statistics. Then, another trick part is, what is inferential statistics?
That when you try to determine whether or not a relationship exists with your numbers.
Yeah, why, whether or not relationship exists? Why? you
Well,
need
a
to determine-
significant relationship. You're trying to find out if there was significance in the relationship or not.
Yes, why you need to find out whether there is a significant relationship? Yes.
You wanna see if you can generalize that from the sample to the larger population?
Exactly. That's why you need inferential statistics, because if you want to see whether there is a relationship in the sample, you don't need to do a statistic test. You now need to see whether there is a significant relationship there. Why significant? You already find the number, you already compute everything for your sample. You already know their mean, their median, their standard deviation, their variance, their relationship. You already know sample distribution. You have the data on your hands. Right? So you need to use some type of likelihood. This is a statistic word, likelihood of probability, to determine whether this relationship you found from your sample exists in the population. So you draw conclusion about your population because not everybody in the population is in your sample. Your goal is to draw conclusion about the population. You want to know about the 7th grade student, how they perform, but you cannot possibly include every single 7th grader in your study. Does that make sense to you? That's why you need inferential statistics. Based on this sample value, you see how likely this relationship can exist in my population. So you estimate the population value based on the sample value through this whole process. This is also called a statistic test. Okay? So the complex part is this part, not the descriptive statistics. Descriptive statistics you just calculate, you just compute it based using the formula. And most of this formula are easy, simple. Right? But the statistic test is a likelihood things. The logic behind the statistic test is the focus of the okay? So why we think this is significant or not significant? Okay, so that is it. So descriptive statistics we already studied, so I don't need to spend much time with you. I just go over and review it. If you don't get it at that time, ask right now, okay? All right, this is the distribution. So 4 types. Frequency distribution, including the frequency tables, the histogram, bar charts, all those that you're familiar with, distribution curves, right? And the averages, or it's another term called the central tendency of the distribution. It's the mean, median, mode. Third, distribution variability. Okay, standard deviation, variance, and the skewness, the kurtosis, okay? The last type, correlation. Okay,
Can you
fourth-
give like a one sentence like synopsis of kurtosis again?
Oh. Skewness, you mean?
Right. I knew skewedness.
Uh-huh.
Are they
Kurtosis is-
interchangeable or?
Skewness is like this, or the positive skewed,
Right.
negative skewed. Kurtosis is, you know, the normal curve, right?
Right.
And it could be very peak, or it could be more flat.
Okay.
This represents the kurtosis.
Okay. That
Okay?
makes sense.
So for the normal distribution, the normal curve, the skewness value is 0. And for the normal distribution, the kurtosis is 1. Okay? So that's why when they test whether the distribution is normally distributed, and then they test how far your skewness from 0 is a negative value, oh, that's why it's called negative skewed, because their value is negative, positive number. And then the kurtosis